Alright, so in this video we're going to look at a specific formula, so the distance formula, not distance as in distance on a plane, but distance as in rate times time. And then we're also going to look at another mixture type problem. So kind of a couple, formula and mixtures kind of together, and we're looking at distance times rate times time on both. So the formula for distance is distance, so the distance you go, that should be a C and then an E, equals the rate you're going times the amount of time that you go that rate. So rate times time equals distance. So this is a very popular, or not popular, common formula. So they're even showing you that they're reducing it down to just the letters here. So D equals RT, so distance equals rate times time. So we're just going to go through and start filling this in. So with this one, it's a tortoise is walking in the desert. It walks for 17.5 meters at a speed of 7 meters per minute. For how many minutes does it walk? So if we think about the question, for how many minutes does it walk? So that means I don't know the time, right? Because I don't know the number of minutes. The distance is going to be either meters or miles or feet. So this is, it walks for 17.5 meters. So that's my distance. And then speed, that is my rate. And we're going to hear something per minute, per hour, something along those lines. That'll let us know that it's a rate. So this is going to be 7, and then it's meters per minute. I don't think we'd actually put MPM on there. We'd probably just write out meters. So now I'm going to go distance equals rate times time, and I'll do T for time. So now to know the number of minutes, all I'm going to do is get T by itself. Since I'm multiplying by 7, I'm going to divide by 7 on both sides. 17.5 divided by 7 is 2.5 equals 7 divided by 7 is 1, so T is left over. So it's 2.5 minutes. Alright, so now we're going to look at distance times rate times time again. It's a little bit of a mixture problem as far as like we're building a table, but the table just helps us organize the information. So 2 trains leave a station 294 miles apart at the same time. So they're leaving at the same time. I know how far apart they are. And they travel toward each other. So they're going toward each other, and this distance is 294 miles. And they left at exactly the same time going toward each other. One train travels 95 miles per hour, and the other travels 115 miles per hour. How long will it take the 2 trains to meet? So hopefully we understand this one's going faster, so it's going to travel a little faster, right? So it's going to go not a whole lot faster, but that's, still 20 miles faster than this one. So for every hour that they're traveling, this one goes 20 more miles than this one does. So this guy's going to get a little farther down the line than this one when they finally meet. They're not going to meet right in the middle, right? So let's go ahead and fill in our table here. So the train number 1, we had 95 miles per hour. And I don't know the amount of time it's going to take it to go the full distance, but it's rate times time equals distance. So I'm going to go 95 times x is 95x, right? And then train number 2, it's going 115. And I also want to know when it's traveled. The distance, the amount of time, because it should be the same amount of time that they're traveling when they finally meet. They start at the same time, so this one's just going a little faster than the other one. Darn it, it turned a little bit. I don't know why I did that. Let's turn that one back. There we go. So it's going to equal 115x. So if I add these both together, remember they're meeting at some point, not quite in the middle, but they're meeting. So they've traveled the entire 294 miles together. So what I'm going to do is add these two together so that I know at what point have they traveled a total 294 miles. So now I'm going to add these two together. 115 plus 95 is 210. X equals 294 miles. And so now all I have to do is divide by 210, and that'll tell me how many hours it's going to take for them to actually meet up at this point. So 210 divided by 210 is 1, so x is left by itself. and we get 294 divided by 210 is 1.4 hours. So not quite an hour and a half, but pretty close to it. They will meet somewhere, not quite in the middle. It's going to be a little bit offset. So it wouldn't be quite like in the middle, in between. It's going to be a little bit farther to the side here because the 95-mile-an-hour train is going just a little slower than the 115-mile-an-hour train. So, and you could go back and plug these in and see actually how far they went. If you went 95 times 1.4, you could see the distance this train went as opposed to the distance that this train went. So you could go back and test that. All they're asking for is how long did it take the two trains to meet, so this is what they want here. We don't necessarily have to go back and plug these pieces in for this problem. All right, so that was our couple problems on distance, rate, and time. So go ahead and go on, Alex, and give that a try.